Welcome to my YouTube channel. In this video, I'm going to discuss the number system. The number system in mathematics is how to represent number. When you have the symbol n, it means natural number. The way when we have this symbol means dollar in finance. And when we also have this symbol is a symbol of naira. So this symbol means natural number. What are the natural number? How does this natural number look like in mathematics? Natural number are number that start from 1, 2, 3, 4, on and on. There is what we also call the whole numbers. The whole numbers start from 0, 1, 2, 3, 4, on and on. But in some texts, you see that natural number will include 0. But in this case of my own definition, natural number start from y. Y, the one that starts with 0, is called whole number. Anytime you see the symbol, is called the set of integers. This is called the set of integers. Why this is called the natural numbers in mathematics? This is how natural numbers look like. How does integers look like? Integers are sets of what? Negative numbers. -2, -1, 0, 1, 2 to a positive numbers. Integers include whole numbers and negative number. So for that, natural number are inside the set of integers. If you have the symbol Q, this is called the set of what? All rational numbers. Set of all rational numbers. How does these numbers look like? These are numbers that are in form of a fraction or a number that when they are given, you can write this as a comma b, for which a comma b are coming from set of integers. B must not equals to 0 and a b belongs to the set of rational numbers. When 1 is given, we can write it as 1/1, for which equals to a equals to 1 and b equals to 1. B is not equals to what? 0. In this case, 1 belongs to set of rational numbers. When 2 is given, 2 can also be written as 2/1, for which a equals to 2, b equals to 1, b is not equals to 0. This implies that 2 belongs to the set of rational numbers. Given -5. -5 is the same thing as -5 divided by 1, for which a equals to -5, b equals to 1, 1 is not equals to 0. This implies that -5 is in set of what? Rational numbers. When -10 is given, -10 is the same thing as -10 divided by 1, for which a equals to -10, b is equals to 1, b not equals to 0. This implies -10 is in set of rational numbers. All the sets of integers is inside set of rational numbers. So all the sets of integers are inside rational numbers because pick any number a from integers. A can always be written as a/1, for which 1 is not equals to 0, b equals to 1, and what? A will always belongs to set of rational number. That is why all sets of integers are inside set of rational numbers. And from above here, sets of natural numbers are inside set of integers. A number belongs to the set of rational numbers if what? If b is not equals to 0 and a comma b are coming from the set of integers. This implies a/b belongs to set of rational numbers. That is, when a number is given, we can rewrite it as a fraction of a/b, for which a comma b is coming from sets of integers and b is not equals to 0. Any number that can be written in a fraction of it as a fraction of integer divided by integer, then we said that number belongs to set of rational numbers Q. Given 3/4, A is equals to 3 and B equals to 4, B is not equals to 0. This implies that 3 over 4 belongs to the set of rational numbers. One whole number 2 over 5. Is this number a rational number or is an integer? Is this a natural number or is a set of integers or is a set of rational number? Of course, one whole number 2 over 5 can be rewritten as 7 over 5, for which A equals to 7 and B equals to 5. B is not equals to 0. This belongs to set of rational number. What if 0.2 is given? 0.2, is it a rational number? Of course, it's very obvious that it can never be a natural number and it's not in set of integers. So let's check if 0.2 can be written as A over B, for which A, B is coming from set of integers and B is not equals to 0. 0.2 is the same thing as, when you shift the point, the same thing as 2 divided by 10, and this is what? 1 over 5. A is equals to 1, B equals to 5, B is not equals to 0. This implies that 1 over 5 belongs to the set of Q, for which A, B is in what? Set of integers. Again, this out of 0.3 with this bar, it is the same thing as 0.3 dots. It's very obvious that this is not coming from set of natural number. 0.3 can never be in set of natural number. 0.3 can never be in set of natural number. 0.3 can also not in set of what? Set of integers. Let's see if we can write 0.3 in form of A over B, A, B coming from set of integers, B not equals to 0, then we can say 0.3 will belong to set of rational numbers. What is the meaning of 0.3 bar? This is 0.3, then 3 keep on repeating. So what is 0.3? This is the same thing as assign x to equals to 0.3. So x is the same thing as 3.3 from here, divide by 10. If you shift the point once, this is the same thing as x is the same thing as 3.33. If you shift the point twice, x is also the same thing as 3.3. If you shift the point 3 times. From here, this is the same thing as 10x equals to 3.333. From here, we have 100x equals to 333.33. From here, we have it to be 1000x equals to 333.3. So from here, x equals to 3 as 0.333 repeated. If given 0.63 bar, this is the same thing as 0.63. In this case, it's very obvious that 0.36 repeated is not a natural number and 0.63 is also not in set of integers. So let's see if we can rewrite 0. as A divide B, for which B is not equals to 0. A, B is in set of integers. This will imply that 0.63 will belongs to set of rational numbers. Let x equals to 0.63. This is the same thing as 0.63. 63 keep repeating. So x is equals to 0.63. So when you shift the point once, we have 6.36 divided by 10. When you shift the point once here, then you have 36. So when you shift the point twice, you have 63 divided by 100. Shift the point 3 times. This is 636. Then the point will be here. After the point, we have 36 divided by 1, 2, 3, because we shift the point 3 times. When you shift the point 4 times, it will come to this side. We have 63 6363 divide by, we shift the point 4 times. So from here, we have x is equals to 0.63636363. But from here, we have that what? 10x is equals to 6.363636. From here, we have 100x equals to 63.636363. From here, we have 1000x is the same thing as 63363. And from here, we have 10,000 x equals to 63.63. So after the points, check which one rhymes together. We have 63 here, 63 here, and then we have 63 here. You can this and this are the same thing after decimal points. After decimal point, we have 63, 63. The same thing here. Again, 10x equals to 6.3636 is the same thing as 3636. This and this also rhyme together. This and this also rhyme together. After decimal point, those that are rhymed together can come together to find the fraction that form 0.63. So x equals to 0.636363 is rhyming with what? 100x equals to 63.636363. So in this case, remove 100x, 63.636363 minus 0.636363. After the decimal point is to go away with this side, then we are left with what? To remove x from 100 as we have 99x, the same thing as 63. Then from here we have x equals to 63 divide 99. If you press it in calculator, you see this is the same thing as 0.636363. So we have found the fraction 63 divided by 99, for which 63 is equals to A, 99 is equals to B, also 99. 63, 99 is coming from sets of integers. This implies that 63 divided by 99 equals to 0.63 belongs to the set of rational numbers. Given 0.234, this means that this same thing as 0.234, and it means 0.234, 234, 234, keep on repeating. To know if this 0.234, 234, 234 belongs to set of rational numbers. So if you can write this decimal point as A divided by B, for which A, B is coming from the set of integers B not equals to 0, then 0.234 will belong to the set of rational numbers. First, let x equals to 0.234, 234, 234. Keep on repeating. X is same thing as 2.34, 234, 234, keep on repeating. Divide by 100 because you shift it once. X is the same thing as what? 23.4234, 234, keep on repeating. Divide by 100, you shift the point twice. X is same thing as what? 234.234, 234, divide by 1000 because you shift the point 3 times. 234, keep on repeating. X is also the same thing as 234, 2.34, 234, keep on repeating. X is the same thing as 0.234, 234, 234, keep on repeating. 10x is the same thing from here. We have 10x equals to 2.34, 234, 234. 100x the same thing as 23.4234. 1000x is the same thing as 234.234. 10,000x is the same thing as 234. So from here, we have 10,000 is the same thing as 234. So after the decimal point, 2342, we check which one is 2342. See, it's the same thing as 2342. So after the decimal point, 23, the first is the same thing as 2342. It's the same thing as here. So you can pick the first as 23 and this. And you can also pick this second 34 with this. So from here we have 100x is the same thing as 234.234. Again, x is equals to 0.234234. So when you subtract, you have 999x is the same thing as 234. So x is equals to 234 divided by 999. Of course, this is the same thing as 0.234 repeated. We have found the fraction where a equals to 234 and b equals to 999 not equals to 0, and 234, 999 is in set of integers. This implies that 0.234 is in set of rational numbers. Check if 0.863 belongs to rational numbers. 0.863 will belongs to rational numbers if we can rewrite 0.863 as a over b, for which a comma b is coming from set of integers and b is not equals to 0. So you first let x equals to 0.863, then x is the same thing as 8.63 divided by 10. X is the same thing as 86.3 divided by 100. X is the same thing as 863 divided by 1000. So from here, this implies that x is equals to 0.863 is the same thing as 8.63. 100x is the same thing as 86.3. 1000x is the same thing as 863. So after decimal point, which one rhymes together? There is no one that rhymes together, so that we can pick the two, subtract it, and check the fraction that form 0.863. 863 is not the same thing as 63 after decimal point. It's not the same thing as 3 after decimal point. So there is no one after decimal point that we can pick together, subtract, and find the value of x to give us a fraction that give this. So 0.863 cannot be written as a over b, for which a comma b belongs to set of integers and b is not equals to 0. This implies that 0.863 is not in rational number. So again, because 0.863 cannot be written as a fraction of two integers. Also check if 3.142 is in set of rational numbers. If we can write 3.142 as a over b, for which a and b is in set of integers and b is not equals to 0, then 3.142 will belongs to the set of rational numbers. Let x equals to 3.142. So let x equals to 3.142. X is the same thing as 3142 divided by 10. X is the same thing as 314.2 divided by 100. X same thing as 3142 divided by 1000. From here you have 10x equals to 31.42. From here 100x is the same thing as 3142. 1000x the same thing as 3142. So if you check, you see that what 3.142 does not belong to the set of rational numbers, because there is no a divide by b for which a and b is the set of integers and b not equals to 0. So 3.142 is not in set of rational number. 3.142 belongs to the set of irrational numbers. Again, from above, 0.863 belongs to the set of irrational numbers. So if you have a decimal that cannot be written as a over b for which a comma b is coming from integers b not equals to 0, then we say the number is coming from irrational numbers. Again, 0.863 is coming from irrational number, because 0.863 cannot be written as a over b, a comma b coming from set of integer and b not equals to 0. Also, square root of 2 does not belong to set of rational number. Square root of 2 belongs to set of irrational number. Square root of 5 does not belong to rational number. Square root of 5 belongs to the set of irrational numbers. The set of real numbers include natural numbers, integers, rational numbers, and irrational numbers is called the real number. That is, or number line. That is, these are the numbers that are represented in number line: -1, -2 to minus infinity, 1, 2 to positive infinity. Natural numbers is inside set of integers. Set of integers is inside set of rational numbers, and irrational numbers are inside set of real numbers. That is inside set of real numbers. For any point between -1 to 0, there are lots of fractions, square roots, set of irrational numbers in between. Note that this subset is used to include a natural number, but in a case where we have a is in what? Is in inside set. This is an element inside a set, but natural numbers is used to what? To make a comparison between two sets. Note that this subset is used to compare two sets: less than, greater than, less or equals to, bigger or equals to. It's used to compare two numbers.